Hello everyone, video 3 of module 4. In this video we talk about defining load cases and load combinations. As I said before, we have three different definitions for loads in SAP: load patterns, load cases, and load combinations. So we talk about load patterns. Load patterns are the basis of loading in SAP. So any load you want to apply on a structure, you need to choose a specific load pattern. What's the difference between load pattern and load case? I will explain now. So to edit my load cases, I can come here into the menu, define load cases, or I can come to define and click on load cases here. So you can see here the name of load cases is quite similar to the name of load patterns you created. Some of them are additional like modal and dead. So what's the difference of these two? I can modify this load case. You can see this is actually self-weight. Why the name is dead? Why the name is not the same as others similar to the load pattern? Because that is the default load pattern by SAP. If you remember, the name of the load pattern was dead and I changed it to self-weight. So self-weight here is correct, but this is initially created by SAP. That's why this is dead. So we will change it to self-weight. I can show you the other options we have here. So load case could be linear or non-linear. Currently we're using linear options for analysis, so keep it this. And then zero initial condition. This is when I explain about p delta loads, I will talk about this option later. That's actually for non-linear options. And here I can choose the load case type. Is that a static or a stage construction, multi-step static, modal, response spectrum, moving load. Here I'm choosing static currently. I can, if I want automatically load combinations to be created by software, I can come here and mention I want to have this load in my combinations or not, for bridge design and for load type. So I will leave it here, but I always create my own load combinations. I will explain you why. So I keep this one as it is, linear, and that modify shows you can put some notes here. If you change any factor, I will tell you how you can change factor and why you need to change factor sometimes. Basically, whatever is the load pattern, you have the same load case with factor 1. That's for all of those elements. So let's move on, and then I will explain you what you can do here with those factors. So what is modal? Modal analysis is what you need for getting the period of the actually different modes for a structure and see which one is the actually fundamental modes for your earthquake design. We're not going through response spectrum and detail of modal analysis, but I will show you basically how to utilize it for your earthquake design calculations. But if I press this one here, you can see the type of load is modal, and it mentioned that, for example, how many number of modes is maximum and minimum that it should be considered in this design. I generally put it minimum for 20, depends on complications, sometimes could be up to even 200, but really back to the type of structure we have. And I'm not going to advanced parameters, very basically, so I will allow the automatic frequency shift for convergence of the result, and also what is the tolerance. So if the tolerance is very high, here is very high tolerance, we can leave it, or we can make it less to reduce the number of iterations and also speed in getting the result. Depends on the level of accuracy you need. And you can see mass source here. We need mass source. We have two types of modes, eigenvalues and Ritz vector. Again, I'm not going through these levels, but Ritz is more accurate generally when you want to achieve 99% of modal participating mass ratio in your modal analysis for earthquake design or response spectrum analysis. We will keep it as eigenvectors for this one, and I will press OK. So superimpose dead load, you can see this is the same. I'm not clicking on all of them, I'm just showing that some of them, I'm just showing that you can see that all of them are the same load pattern with factor 1. But when you're coming here, you can see we have EQX. Then I have other earthquake load that I have. So those are what I created. So if you come here, you can see QXP1. So I can delete this load case, and then the rest is what I have. Again, if you remember, SAP automatically created WindXP 1, 2, 3, 4. I changed this one to WindXP, the one I have, but these three are still here. So you can come here and select them one by one and delete them. Okay, so those are completed. Now, how can I leverage this for my load combination calculation? In load combinations, you always use load cases. So if you don't have any load case, you cannot come to load combination and use it. How we can simplify our load combinations? So you see we have different categories of loads. For example, self-weight, superimposed dead load, wall load, but actually all of them are dead load. So you can come here and simply add new load case and put the name of load case, for example, dead. And then you can come here and say, okay, load pattern. I want to choose self-weight by factor 1. I want to use superimposed dead load by factor 1. And I want to use wall load by factor 1. So instead of using self-weight, superimposed dead load, and wall loads in my load combination, I can simply choose dead load in my load combination. So that's just simplify my load combination definitions. So that would be less workload for me. So anything else we can add? We have just one type of live load, which is okay. Soil, I prefer to keep it separately, and the rest can be separated. You can combine this wind and earthquake loads, it's up to you, but I want to see them in my load combinations. I think would be easier. Otherwise, you know, for example, in many seismic provisions, you have 100% of earthquake in one direction plus 30% of earthquake in the other direction. So you can prepare these combinations here, and for example, 100% XP plus 30% YP, then 100% XP plus 30% YN, and likewise for this. And then you use this one. But because there are positive and negative directions, I prefer to keep it as it is and just use it in my load combinations calculation. So this is for load case. What else you can do for load case? This is good but a little bit dangerous. For example, your client may change the type of wall. So you already apply all walls in the building based on, for example, precast concrete. Then they want to change it to lightweight cladding. Suddenly the load of the wall dropped to 20%, 10%, or whatever based on the material, 50%, depends on whatever you use, of what you define. Instead of going back to the model and change all those loads one by one, you can come here and simply change this factor to 0.2, 0.5, or whatever you want to change. I'm saying this is dangerous because you cannot see this anywhere. Even when you check the loads on the element, you see the original wall loads application. But this factor is hidden in load case. You can put a note here for yourself that why it's happened. That's how you can use this note. But this note wouldn't be anywhere. You need to have something as a history of your model out of the model in a Word file and explain what's happening. So people will realize that why this scale factor is changed, because it's not visible in your analysis. Be very mindful, guys, when you're using these kind of factors, because if somebody else wants to check your model, or anybody after a few years wants to get back to this model and use it for any kind of development or renovation, they may not realize that what you have done. Okay, so this is generally what we can do for load cases, and I press OK. Now let's define load combinations. So to define load combinations, again in top menu you can see here define load combinations, and the other option is coming here in define, and go for load combinations. So here you have two options: either add new combos and you go ahead, or you can use add default design combos. If you want to use default design combos, you need to see what type of a standard here you use for your design. I have to go a little bit forward and show you what you need to do. So when you come in here for preferences, you need to choose the standard here. Currently the standard is AISC 360, which is American standard. I don't mind to leave it as it is because I'm not using automatic generation of load combinations. So this is based on AISC, could be Australian standard or anything else. So this is Australian standard for steels, for example. I will leave it as it is, which is AISC. So this is for concrete. I'm coming here, I can see this is ACI. When all those factors are here, you can even play with this factors, utilization factor limit. You may put it 100%, even 105. Depends on the criteria you want to have and the risk you want to take in your design. Could be even less, could be 80%. And what's the pattern live load factor and other options that you have based on your local standards. So I will keep it for American standard, and then I'm coming to load combinations, and if I come to default design combos, I can choose a steel frame, concrete, aluminum, or cold form. So let's go for a steel frame, set load combinations data. Currently all load cases you have are in the right side. That means all of them are chosen to define load combinations. Is that correct or not? You need to see. So you define dead load for self-fade and superimpose dead load and wall load. That means they shouldn't be here, but you can see superimpose dead load. You need to move it back here. That means I'm not using this load case. And then self-fade and wall. You can press Control and you can select multiple of actually loads and then put them here. So do you need earthquake? Yes, I need earthquake. Live load? Yes, I need. Snow? Yes, I need. So those loads are here. Okay, so for example, you can't see here the displacement loads or thermal loads, and you need to see how you want to add them here. So here it is based on this strengths, and this is the limited state that you use. So if you press OK, then here come and press OK, you can see all those loads are created automatically. Is that correct or not? So let's have a look. First of all, the name of the loads should be understandable for you. When you see here 1 to 45, you have no idea which one is for wind, which one is for earthquake, which one is for gravity. So I will give you some hints and tips about name of the load combinations. When I'm coming here, I see this is just for dead. When I come to the second one, I see dead and live and snow. And then this one is again another combination of dead and live and snow. Let's move on a little bit faster. So some of them. So here this is snow and wind YN. Yeah. And then here again another combination for wind YN negative. You can see SAP doesn't understand that when I say negative or positive in direction we have different wind ward and leeward. So it apply wind load one by one in positive and negative direction, which is not correct, because when we say wind YN, that means in this building wind YN is this way. That means this is windward and this is leeward. So you have different wind pressure here. So if you put it -1, that means you simply reverse it. But now this is windward, so the load here is different with leeward, but currently you apply just leeward here in this load pattern. So it is not correct. Even it's not that simple just about windward and leeward, because you have a combination of different wind loads on elements. For example, you have wind in X or Y direction, but at the same time you have internal wind pressure, you have roof wind load, and you want to apply all of them at the same time. So you have one load case for internal wind pressure, one load case for roof wind load, and one load case for windward or leeward on the walls. So that means you need to see at least 3 load cases here. But SAP doesn't understand. SAP applies wind loads one by one in different combinations. So if we move on, you see that if I come here, this is XP, and then this is the same with factor minus. That is applicable for earthquake, as I explained before, but not for wind load. That's why I'm not very fan of using standard load combinations for my design. If you use automatic wind and earthquake load calculations and you really can manage everything properly, then that's perfectly fine. If it's a simple building that you just have a, for example, simple dead and earthquake load, something inside a warehouse that you are designing and you have simple combinations, you may use standard load combinations. But again, you have different load combinations for steel and concrete, so you need to figure out how you want to create them. So this is STL. You can see UD STL. That means ultimate design steel. So if I press cancel and then again come to load combination, and this time I choose concrete frame, you can see it's coming as ultimate design concrete. So you have again some numbers here, but you cannot figure out which one is for gravity, which one is for earthquake, which one is for wind. So that's why I'm not using those.